Hello friends, welcome to Learner's Planet. Friends, this is our first session for similar triangles. In this session, we are going to discuss about similar triangles. What are similar triangles? What are the basic properties and conditions for the two triangles to be similar, right? So you might have studied about properties and basic terminologies related to triangles in your junior classes. So straight in this session, we are going to discuss similar triangles. So let's begin the session. Now friends, in your junior classes, you might have studied about congruent figures. Now what are congruent figures? If two geometric figures having the same shape and size, we call them as congruent figures. That means if one shape can be superposed on the other and clearly superposed, then these two shapes are known to be a congruent figure. Suppose I have these two circles. Now radius of the circle and radius of the circle is same, right? So if I put this circle over here, over in this circle, then it will be superposed, right? That means none of the part of the circle will be seen outside, right? That means these two circles are congruent, right? Similarly, we can see these two squares, length of this side and this side is same. That means if I put this square over here on this square, then it can be superposed easily and none of the part of this square can be seen, right? That means this square and this square, both of them are congruent figures. Similarly, if we talk about these two triangles, right? If I impose this triangle over here, then none of the part of this triangle can be seen. That means these two are congruent triangles, right? This length is equal to this length is equal to this length, and this length is equal to this length, right? So the two triangles are known to be congruent, right? So congruency, you understand that the shape and size of two geometric figures is exactly the same, then the figures are known to be congruent. Now I introduce here a new term, that is similarity. Now in case of similarity, what happens? The shape is same but size is not the same, right? In case of congruency, shape and size, both of them are same, but in case of similarity, shape is same but size is not same, right? As we can see these two circles, right? This is also circular, this is also circular, but if I put this circle over here on this circle, obviously this circle will not be able to occupy this complete space, right? You can see the portion of this circle outside this circle, right? But these two are symmetric figures, right? That means what I can say, the shape of this and this is same. That's why these two circles are similar circles. That means we can say all the circles are similar to each other, right? If their radii are equal, then they will be congruent. If their radii are not at all equal, then they will be similar. Similarly, if I talk about the squares, these two squares are congruent to each other because they can be superimposed, or one square can be imposed on other. But if I compare these two squares, the side of the square is clearly bigger, right? The square side is clearly bigger. That means these two squares will be similar but not congruent. That means their shape is same but size is not same. Similarly, we can talk about these triangles. These two triangles are congruent to each other because their shape and size, both of them are same. But in case if we talk about these two, their shape is same but size is not the same. That means these two triangles are similar triangles, right? So if I compare between congruency and similarity, I just wait for a moment. So in case of congruence and similarity, here shape and size both are same. Here only shape is same, size is different. Okay, so precisely all the circles will be similar to each other, all the squares will be similar to each other, right? All equilateral triangles, we can say, will be similar to each other, isn't it? All isosceles triangle, we can say, will be similar to each other. if there are two angles of these isosceles triangles are same, right? In case of equilateral triangles, all the three angles are 60 degree. That means all the equilateral triangles will be similar to each other. But in case of isosceles triangle, if two angles are same, then only they will be similar. So the concept of angle in the case of similar triangles we'll discuss later on, right? Till now we have discussed the difference between congruence and similarity. In case of congruence, shape and size both of them are same. In case of similarity, only shape is same, size is different. Okay. So friends, from this discussion we can draw one more conclusion, that in case of congruence, shape and size both of them are same, and in case of similarity only shape is same. So precisely what is happening over here, all the figures which are congruent, they will be similar also, right? Because in case of similarity, shape should be same. So all the congruent figures are having same shape, right? So all the congruent figures are similar, but it is not necessary that all the similar figures are congruent, because in that case size may be different, right? So in case of fill in the blank question in MCQ question, this sort of concept may be discussed or may be asked in your exams, right? All congruent figures are similar, but all similar figures or the similar figures need not to be congruent. Okay. Now friends, we have just discussed the concept of similarity of circle, for the square, and for triangle we have just discussed, right? The same theory can be extended for any polygon, right? So any two polygon of the same number of sides will be similar if their corresponding angles are equal and their corresponding sides are in the same ratio, or maybe we can say proportion. Suppose I have given the example of two parallelograms over here. So this side and this side, obviously these two sides are same, and here these two sides are same, and these two sides are same, and these two sides are same. Now the sides should be in proportion. Suppose it is x and it is 2x. Suppose it is y, then it should be 2y, right? So if it is x, it is 2x. If it is y, then it should be 2y. So the ratio of the sides should be same, and this angle, corresponding angles must be same, right? Then these two parallelograms will be similar. Okay. So what is the basic condition of similarity? Corresponding angles should be equal and their corresponding sides should be in the same ratio. In case of congruency, their corresponding sides should be same, right? Should be same, right? And here the corresponding sides are in the same ratio, right? So suppose this is a triangle and this is a triangle. This maybe this is an equilateral triangle, this is an equilateral triangle. So in case of equilateral triangle, all the three angles are equal, right? Now this length is suppose 2, this is 2, this is 2, right? This is 4, this is 4, this is 4. Then these two triangles will be similar, okay? Because the three sides are in proportion. Okay, so I hope you are getting me. So friends, now we discuss about similar triangles, right? Now two triangles are considered as similar if their corresponding angles are equal and their corresponding angles sides are in the same ratio, right? Or proportion, right? I have this triangle and this triangle, both of them are equilateral triangle. So here we can see they are congruent, right? Now I have one more triangle over here. Wait for a moment. Now this is also an equilateral triangle. So these two triangles are congruent, but these two are similar to each other. Since this angle is equal to this angle is equal to this angle is equal to this angle, right? The sides are in proportion. That means A, B, C, X, Y, Z, right? So A by X is equal to B by Z is equal to C by Y, right? That means the sides are in proportion. That means these two triangles are similar, right? So what are the conditions? Their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. I give you some more examples over here for similar triangles. Now we have these two triangles. This is A, B, C. This is P, Q, R, right? Now this angle is of 120 degree. This angle is 30 degree. This angle is 30 degree. Similarly, this angle is 120 degree. This angle is 30 degree. This angle is 30 degree. Okay. So we can see the three angles, that is angle A, angle B and angle C, are equal to the corresponding angles of this triangle. That is angle A is equal to angle P, angle B is equal to angle Q and angle C is equal to angle R. That means triangle ABC is similar to triangle PQR, and this is the sign of similarity, right? Triangle ABC is similar to triangle PQR. Now if the two triangles are similar, their sides will always be in ratio. That means I can say AB by PQ is equal to AC by PR is equal to BC by QR. Okay. So if the two triangles are similar, their sides will be in ratio. And when the two triangles will be similar, where their angles are equal, right? Corresponding angles are equal. Okay. Now friends, a famous Greek mathematician Thales give an important truth relating to two equiangular triangles, which is the ratio of two corresponding sides into equiangular triangle is always the same. It is believed that he had used a result called the basic proportionality theorem, which is now known as Thales theorem, right? So Thales theorem is going to be an important theorem for examination, from examination point of view. So we'll discuss this theorem in detail, right? And you can be asked about the derivation of this theorem also, or like proof of this theorem also, right? So it's going to be important. So just observe each and every step carefully and do it or learn it by writing it 2-3 times, right? So let's take this. Now we discuss basic proportionality theorem, or we can say Thales theorem. If a line is drawn parallel to one side of a triangle to intersect the two other sides into distinct points, then the other two sides are divided in the same ratio. That is Thales theorem, or we can say basic proportionality theorem. A number of times the theorem is asked in your board exams, so you need to be very much clear about it. Just watch the theorem carefully and do write it 2-3 times, right? So you can learn it very well. And the application of basic proportionality theorem or Thales theorem are also very important. We'll be doing problems based on the theorem, right? So first of all, what's given to us, I just write how to write the theorem in your exam, right? What is given? Suppose we have a triangle ABC, right, in which we have a side, or we can say a parallel line to BC we are drawing. Suppose it is DE. What I do, first of all draw a diagram over here. That would be better. Now I have this triangle. I suppose this triangle is A, B, C. Now a line is drawn parallel to one side. So I draw a line parallel to BC, that is DE. A line is drawn parallel to one side of a triangle to intersect the two other sides. It is intersecting AB at D, intersecting AC at E, two other sides into distinct point. Then other two sides are divided in the same ratio, right? That means what we have to prove? AD by DB, to prove AD by DB is equal to AE by EC. And it is very, very important. The theorem itself and its applications, right? So if a line is drawn parallel to one side of a triangle that intersect the lines, the other two lines at two distinct point, and that means if we match this 2 points, then we'll be getting the line DE, and DE will divide the sides in the same ratio, that is AD by DB is equal to AE by EC. Now friends, to establish this theorem, we need to go for some construction. So I just draw the construction for you. First of all, what we have to do? We have to match this B to E and C to D, right? I just do it. B to E and C to D, right? Then we draw a line that is perpendicular to BA from E, right? So here that is maybe we can say that is a line EF that is perpendicular to BA, and similarly a line from D on AC that is also perpendicular to AC. So that's this, right? So I assume this point to be F and this point to be G, right? Now friends, we calculate the area of triangle ADE. Area of triangle ADE. Now what is the area of any triangle? That is half base into altitude. Now here it will be half, base will be I'm talking about ADE, so ADE, this triangle, right? So AD is base and EF is altitude, right? So half AD into EF, right? Similarly, I find the area of triangle DBE. So in case of DBE, base is what? Half. Base is what? BD. And altitude is what? EF, right? This is the triangle. This is the base and this is the altitude, right? That means height of the triangle. So it's EF, right? So this is first step, this is second step. So if I find out the ratio of areas of these two triangles, that is triangle ADE by triangle DBE, that will be equal to half AD into EF, half AD into EF by half BD into EF. Now EF, half and half is cancelled. That means ratio of area of triangle ADE and DBE will be equal to AD by BD, right? Now this is an important result. Okay, now let's move forward. Now friends, we can calculate the area of triangle ADE and in a different manner also. So ADE, in that case base is AE and altitude is DG, right? So area of triangle ADE is equal to AE, that is base, and DG, that is altitude. So half AE into DG. Similarly, we can calculate the area of DEC, triangle DEC. Half DEC, base will be EC and altitude will be DG, right? So we can calculate the ratio of ADE and DEC. So area of triangle ADE by area of triangle DEC is equal to half AE into DG, half EC into DG. DG cancel, half cancel. So that is AE by EC. Now we have one more important result. One is this and other is this. Now we have the two triangles DBE and DEC. DBE and DEC. I just changed the color. Wait for a moment. Now you can see the two triangles DBC and EBC. The two triangles are between two same parallel lines, right? DE is parallel to BC. That means the two triangles are between the same parallel lines and they have equal and the base is also same, that is BC. That means area of triangle BDC will be equal to area of triangle EBC, right? So here we'll be equating the area of DBE as DEC, right? That means DBE is DEC and the numerator is common, that is ADE and ADE. That means AE by EC must be equal to AD by BD. AE by EC must be equal to AD by BD, right? Now AE is what? AE by EC is equal to AD by DB or BD, right? So that the thing that we had to prove. So this is what the basic proportionality theorem. Again, I am going to mention over here that it's going to be very important. The proof of theorem can be asked for 4 to 6 marks in your exams, and the problems based on BPT, that is basic proportionality theorem, may also be asked, right? So a very simple concept, friend. You need to draw the diagram. After that, you need to take the area of the two triangles and you have to compare them. That's it, right? Write it for 2 to 3 times so you can write the same in your exams as well. I hope you are clear. Now friends, using basic proportionality theorem, we can establish some more results. Suppose this is ABC and this is the line DE parallel to BC. That means according to basic proportionality theorem, AD by DB is equal to AE by EC, right? This is the basic proportionality theorem. Now what I do is I just add 1 to both the sides. So AD by DB plus 1 is equal to AE by EC plus 1. So if I take LCM, AD plus DB by DB is equal to AE plus EC by EC. Now AD plus DB is what? AB by DB is equal to AE plus EC is what? AC and by EC. So that is also going to be an important conclusion or result, right? Similarly, what I can do, this is basic proportionality theorem. I just write the reciprocal of the same. So DB by AD is equal to EC by AE, right? Now I add 1 to both the sides. So DB by AD plus 1 is equal to EC by AE plus 1. Further I take LCM. DB plus AD by AD is equal to EC plus AE by AE, right? Now DB plus AD, DB plus AD is AB only. So it's AB by AD is equal to EC plus AE will be AC and this is by AE, right? So this is also a result, this is also a result, right? So precisely if you know basic proportionality theorem, various results can be established. AD by DB is equal to AE by EC, that is the basic proportionality theorem, okay? Now friends, similarly we can discuss other theorem, that is converse of BPT, that is basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. Now what is happening over here, I have a triangle ABC and line DE that is dividing the side in the same ratio, that is AD by DB is equal to AE by EC, that is given, right? I just write it over here. AD by DB is equal to AE by EC. Okay. Now what I have to prove? I have to prove that DE is parallel to BC. Okay. Now to prove this theorem, what we do? We take some other point F over there on the line AC. Okay. And for that we use a contradiction. What we do? We assume that DE is not parallel to BC. That means there should be some other point on the line AC, suppose it is F, so that DF is parallel to BC, because at least one line will be there, so that will be like parallel to BC. So I assume DF is parallel to BC. Assume DF is parallel to BC. Now if DF is parallel to BC, so according to BPT, that is basic proportionality theorem, AD by DB must be equal to AF by FC, right? AF by FC, because DF is parallel to BC. So according to basic proportionality theorem, AD by DB is equal to F by FC. But what is happening over here? We are given that AD by DB is equal to AE by EC. That's already given. So AD by DB is equal to AE by EC, that is already given. That means AF by FC must be equal to AE by EC. That means E and F should be the same point, right? That means DF is not a new line. DF, the line is actually the line DE only, right? So friends, this is the converse of basic proportionality theorem. In this session we have discussed many things, and we'll be taking problems based on similar triangles in our next session. So do revise this session, because basic proportionality theorem is very important, and we'll be discussing its applications in our next session. Okay, bye bye.